Hey guys. So, I was looking around through. Okay, so many years ago, my bedroom was upstairs. And then when I was like 4 or 5, everyone's bedroom moved downstairs. So my bedroom is now downstairs. It's still where it is now. And my dad's bedroom was moved to here. I'm laying on his bed right now. And yeah, and my old room became a storage room. And a lot of random crap got put in there. And it's filled up with a whole lot of random, you know, stuff. It's filled up with a lot of random stuff. And yeah. So I was searching around up there and I found 4 adapters, 4 little power supplies. And two of them were for a telephone. And like an old telephone, mechanical keypad, has a wire hooked to it. Take it off the wall and put it on your ear when it goes drrrring. It was one of those. They had 2 adapters for those. They were white. One of them had AC output, the other one had DC output. And a third one was the power supply for my baby monitor. I was talking to my dad and I was like, this one says safety first on it for some reason. That must be a brand. I was like, oh, yeah, that was the adapter for your baby monitor. And yeah. And then the fourth one was this one. This is the only black one. All the other 3 were white. And these ones were quite big. Because they're not new. They're definitely not new. And yeah. They were all 9 volts. 3 of them were DC and 1 of them was AC. This one, I looked at the back of it and I noticed there was screws. I've never seen screws on an adapter before. All the other adapters, they're like clicked and glued shut. This one has screws. So I took the screws out and look at that. Check that out. That's the inside of an adapter. So, what's in here is, you can see this big block here is a transformer. There's your input wires, your 120 volt. This is perfectly safe to touch because it's not plugged in. Well, then again, the output, the capacitor right there, may still be charged. So, I'm gonna plug this in. Click. And short that out. There we go. Now there's no more power in here, and all the wires are safe to touch. And yeah. So it's got the 2 input wires, so 120 volt inputs, and 4 output wires for some reason. I don't know why it's got 4. Most transformers I've seen that have 4 output wires usually have 2 different output voltages. But this only outputs 9 volts and 9 volts only. So, maybe it outputs 3-phase AC. But I don't know how 3-phase AC works. So it's probably not that. But heck, it might output 3-phase AC. But again, I don't know. 3-phase AC requires 4 wires. And in there is a rectifier. So we've got, you can just barely see it. It's inside of this clear tape. It's underneath this clear tape is a rectifier board. It's got your diodes on it, your diode bridge. And on these little wires that are insulated with fiberglass, the orange and yellow stuff, there's some little ceramic capacitors, like that orange circle right there. That's a ceramic capacitor. There are 1, 2, 3, 4 right there. And a capacitor. 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 Caps upsitter. Erps upsitter. Erps erpser. Oh, wait. No. It's not 3-phase. It's got only 2 output wires. The 2 middle ones are output the transformer. But these ones are the output of the rectifier. Those come out of the rectifier board. Those 2 in the middle go into the rectifier board, and these 2 come out. I thought these were all connected to the transformer, but nope, only the 2 middle ones. And yeah, so those two go into the diode bridge, and they come out of the diode bridge and go into the capacitor. And they come out of the capacitor, and they go out the output wire. And what are those ceramic capacitors for? I have no idea. But they're there for something. They do something. And they're connecting to different parts. So one of them is connected to one AC terminal and the positive DC. One's connected to the negative DC and the other wire of AC. One's connected to... It's really hard to freaking see, man. It's hard to look in there. I don't want to move these or else I'll break the thing. Well, I guess I'll move it just a little bit. Take out that capacitor a little. Oh, look at that. It doesn't have an X on it. Huh. And also, another indication that this is old, look at what the capacitor says on it. I think that's upside down, isn't it? Yes, it is. $3,300 MFD. MFD. Seriously? MFD. What? It's supposed to be UF. Like a lowercase u with a little line on it, for some reason. Lowercase u with a little line, which means micro, and then a capital F, which means farad. Instead of that UF, it's MFD, microfarad. That's also an indication that this thing is not new. But yeah, the thing says MFD instead of UF for microfarad. And yeah, and you can just clearly tell by how it's designed. It's not new. It's not new. And yeah. So I found out that there's actually certain adapters made for musical equipment. And I'm pretty sure the difference between a normal adapter for other things and a musical equipment adapter is musical adapters have a much, much bigger capacitor. They gotta be so tightly rectified to get rid of as much of that bzzz as possible. Because after it goes to the diode bridge, yes, it's DC, but it's not even DC. Like, the DC is not quite evened out. Instead of going like +9, 0, -9, plus 0, +9, 0, -9, 0, +9, instead it's going +9, 0, +9, 0, +9, 0, +9, 0. It's doing this. Like something, like, looks like it's jumping. That's what the wave looks like. Because the diode bridge, it opposites that negative wave. So it goes positive, and it goes negative. But that diode bridge makes that negative one, it flips it, and it makes it go positive. So it's just, instead of, it's like, so after it rectified, it is DC. It is only going one direction, but it's not smooth. It's bumpy. It's not a full, it's not perfect DC. That's why rectifiers have a large capacitor on them. Like this one's 3,300 microfarads. And, yeah. So, musical adapters, they've got to have, bigger capacitors to get rid of as much of that bumpiness as possible. Because you can never have 100% fully rectified DC. That does not exist. You can get closer and closer and closer and closer and closer, but you can never quite reach 100% DC rectifying it. The only 100% DC that exists comes out of chemical reactions, which are what batteries are. Batteries are a little chemical reaction inside of a metal tube. That chemical reaction makes electricity. Yeah, that's the only perfect DC that exists, is from chemical reactions, batteries. It can never ever come from a rectifier. DC from a rectifier always has a little bit of a bump, a little bit of a wave. No matter how big your capacitor is, there's always a little bit of bumpiness. And if you're doing musical equipment, like an amplifier, or pedals for a guitar, or a keyboard, or something like that, you want as little of that bumpiness as possible. Because you want your guitar to just go down. You don't want to have that bzzz in the background. You don't want that. You want it to be as perfect as possible. So you need the bigger capacitor, bigger capacitor, bigger capacitor. The bigger capacitor, the better. And yeah. So, if you take a speaker and you hook it up to an adapter like this, you plug it in and it does make a very quiet little bzzz, then it is most likely not a musical adapter. Then again, speakers are very, very low, like, resistance. They use up a lot of electricity. They're only 8 or 4 ohms usually. And that's not much resistance at all. That sucks. That will completely suck up a capacitor very, very fast. It's nearly a short circuit. It's not quite a short circuit, but it almost is. That's why you need such big capacitors for musical equipment, because musical equipment, it's all about speakers. It's all about turning a signal from an instrument into electrical charge for these massive speakers. You don't want those speakers to be making a bzzz sound. And speakers, they have very, very low resistance. So the only way you're going to get rid of that bzzz is by using capacitors bigger than this. This is a 10,000 microfarad. This is 3 of these. 3300, 3300, 3300. So, 9900. That's almost 10,000. So yeah, this is a little bit more than 3 of these. And it's so much bigger, because this is 75 volts. And this is only 16. And there's 2 of these in the thing I took it out of. They're 75 volts, and they're 10,000 microfarads each. There's 2 of them, and they're in parallel, so 20,000 microfarads. What type of thing would need 20,000 freaking microfarads of capacity and 75 volts? An amplifier! That's exactly what this is for. This is a musical equipment, capacitor. This was inside of an amplifier. That's meant to get rid of that bzzz. That's why it's so big. That's why there was 2 of them. And that's why it's 75 freaking volts. And yeah, there's some info about adapters and musical adapters and why capacitors are so important in rectifiers, and just some info about AC and DC, you know. And there's that. And yeah. Now that I think of it, this might be a musical one, because it was in Because that stuff in my old room, a lot of that is musical equipment. Because my dad used to be a DJ for many years, until 2001. So he has all these speakers, and all these mixing boards, and all these amplifiers. So he's gotta have a lot of sound equipment, adapters. That's the word. It took me a while to load. But, yeah. So I'm guessing this is a musical adapter. Let's plug in a speaker and see. Alright, I've got a speaker. This one is 8 ohms. And I've got my baby monitor, adapter. This is obviously not a musical adapter. So we're gonna compare these two, sounds that come out of these. So, I'm gonna attach the speaker to this little adapter thing. Bull crap. I glued that so that that wouldn't freaking happen. What the frick? Well, that's disappointing. I glued that specifically so that that wouldn't happen. Why did it happen? Weird. Okay, I got another freaking speaker. It's exactly the same type of speaker. Yes, solder attaches your wires to other metal connections, but that makes them 10 times easier to break off. Because now they're solid. These wires, they're perfectly fine with bending over and over again. But the moment you make the wire inside of them completely solid, they really don't want to bend, and they just break. That's why that's the bad side of soldering. It makes your wires so delicate. It gives you a good connection, yes, but it doesn't make them very strong. Now, I'm gonna plug this in. Very faint hum. Now, I'm gonna plug in my baby monitor one. This one is the one that goes bzzz when you plug it in. Get it in there. There we go. This one is a little bit louder. I got a few more adapters. So, if you notice, when I plug this in here, there's the buzzing sound. Then, when I attach, stay up, when I attach this capacitor, boom, the buzzing is gone. It's just gone. That's what these are for. Those humongous ones. They get rid of the buzz. This one is the phone one. Yeah. Oh my god, excuse me. Oh. Oh, no, this is the baby monitor one. The other one there is a phone one. This is the baby monitor one. Because it goes bzzz when I plug it in. Yes, it is noticeably louder. The buzz is noticeably louder. Now I've got this one. This one's only 6 volts. I love how these all have the same size plug. It's awesome. Oh, wow. That's barely got a capacitor at all. That's only 6 volts, and that's very loud of a buzz. Unplug that. Plug in this Hitachi one. Alright, now 6 volt. Yes. Okay, that Hitachi one is definitely a musical adapter. Because this is only 6 volts. And this is 9 volts. But the buzz is so much quieter. So yes, that Hitachi one is definitely a musical adapter. So the buzz is so faint compared to the other ones. If 6 volts but has a louder buzz than 9, then that 9 volt adapter has definitely got a much better rectifier in it. So I'm just going to wrap these back up. There we go. Goodbye.